Welcome students, here I am Dr. Amjad Ali. In this video we will learn another method to deal with the autocorrelation, that is Hendry and Mizon 1978 dynamic model. Dear students, as we know that one of the main assumption of OL is that the covariance between the two errors is equal to 0. This means that the two errors are not equal to each other, they are not correlated with one another, and they are independent of each other. But if the covariance between the two errors is not equal to 0 and the two errors become equal to each other, they are correlated to each other, or they are no more independent of each other, so this phenomenon is known as autocorrelation. Dear students, we have now learned much about the detection of the autocorrelation that is done with Durbin-Wasserman test, Durbin H test, and Godfrey LM test. Now we are discussing the removal of the autocorrelation, and in this video we are particularly discussing about the dynamic model which is presented by Hendry and Mizon 1978. Okay, dealing with the autocorrelation is the main issue, or removal of the autocorrelation is main issue for the time series data. Okay, if the form of the autocorrelation is known, then you can use GLS, generalized procedure or method for your empirical analysis. There are three famous methods have been used for the removal of the autocorrelation. First one is Autocorrelation 1949 model, dynamic models, and static models. Autocorrelation model and static models have been discussed in a separate video. Here we are focusing on the dynamic models, and specifically the model of Hendry and Mizon 1978. Okay, Hendry and Mizon 1978 method of autocorrelation, they mention that autocorrelation is an opportunity rather than a problem. They explain that the serial correlation or autocorrelation in the error arise due to misspecified dynamics. It is possible, normally we suppose that whenever we are estimating any regression line, we suppose that the dependent variable can be explained by are independent variables, and the remaining part is explained by the error term. But actually it is not always true, or it is not always possible. Let we have a y is equal to y hat plus u hat. So this reveals that our dependent variable is explained by our estimated, and estimated, you know, the estimated y t is depend upon independent variable, so that's why we are not using independent variable here. So our estimated yt plus error term, so this shows that our dependent variable is explained by itself, is not by itself but by its explained variation and error term. As we know that y hat, this yt is depend upon beta 1 hat plus beta 2 x2t plus beta 3 xt, so on. So this reveals that a number of independent variable have decide the value of the explained variable. So that's why we are including here as a independent variable, explained dependent variable. Okay, autocorrelation in the residual is often caused by a dynamic structure of the y that has not been modeled while estimating. So keep it in mind, there are many cases when we are estimating the dependent variable, but we are ignoring the dynamic structure of the model. In other words, sometimes y needs a richer structure for its explanation, but researchers ignore it. This creates an issue of autocorrelation in the error term. Dynamic model. Let we have yt is equal to beta 1 plus beta 2 x2t plus beta 3 x3t plus beta 4 x4t plus beta 5 x5t plus so on. So this is a dynamic model in nature, and this presents a contemporaneous relationship between the variables. This shows that a change in one or more of the explanatory variables at time t causes an instant change in the dependent variable at time t. Okay, this method can easily be extended to the case where current value of yt depends on previous value of yt or on previous value of one or more of the explanatory variable. It may be there may be chance that that the dependent variable is depending upon its lag as well as the lag value of explanatory variable as well. Okay, let yt depends on sum of current and lag variable, like we have a yt is equal to beta 1 plus beta 2 x2t so on. So see here we have a gamma yt minus 1 plus gamma x2t minus x2t so on. So this regression line shows that our dependent variable is dependent upon current explanatory variable's value as well as its own lag dependent variable as explanatory variable and the lagged value of the explanatory variable as well. Okay, it is of course possible to extend this model even more by adding further lags. This model can be extended. You can include number of lags as much as your model or your data allow you. Model containing lags of the explanatory variables are known as distributed lag model. If you cannot include the lagged value of your dependent variable as an explanatory variable, your model name is distributed lag model. But if you include the lagged value of dependent variable as an explanatory variable and your explanatory variables also include the lagged value of explanatory variable, so this model is known as autoregressive distributed lag model, which is very famous, and in coming session we will discuss extensively about the ARDL models and normally in time series analysis ARDL is the best regression equation for the analysis. Okay, in an ARD model there is no issue of the autocorrelation, because if we feel there is autocorrelation issue in our error term, we can increase the number of lags, because until the autocorrelation exists we can increase the number of lag. So that's why ARDL model considered best for empirical analysis. Okay, another remedy for the autocorrelation of residual to switch model into first difference rather than level. In previous session we see that we only include the lagged value as an explanatory variable and we remove the autocorrelation, but here in this case we are including our variable difference as an independent and explanatory variable as well as dependent variable. So when we use the difference variable, then there is no issue of the autocorrelation remain in our error term. So we have a delta yt. This is the difference value for the our dependent variable yt minus 1. So this is the formula for the first difference. Okay, for the independent variable, if you have a independent variable explanatory variable x2, delta x2 is equal to x2t minus x2t minus 1. If you have a x3, you can use delta x3t is equal to x3t minus x3t minus 1. So on. How many variables you have, you can include their difference. Okay, this can be explained as delta yt is equal to beta 1 plus beta 2 delta x2t plus beta 2 delta x3t plus ut. Here in this case our error is white noise and there is no more issue of autocorrelation. Okay, sometimes the change in y purported to depend on previous value of the level of y as well as change in the explanatory variable. Okay, see here we have delta yd is equal to beta 1 plus delta beta 2 delta x2 t so on. So see here we have differenced variable, but the lagged value of dependent variable is also affecting our dependent variable, difference the dependent variable. So if you run this regression line or this regression line, there may be no chance for the autocorrelation presence. And here we have the error white noise error term with blue property, as well as we have error with the zero mean and constant variance. Okay, in this model there is no more autocorrelation among the residual. Okay, this is all about the removal of autocorrelation with the Hendry and Mizon 1978 model. You can say that is a dynamic model. Okay, see you with another video. Ciao.